So when I apply this to the inverse cos, let's see what we get. Let's change colors. Well, I know this. I know that the cosine of the arc cosine, or the inverse cosine of x, equals x when? Well, remember, cosine can only spit out values between -1 and 1. So this is for x between -1 and 1. All right. Also, similarly, I know that the arc cosine of the cosine of x equals x, but only, remember, arc cosine can only spit out values between 0 and pi in the first two quadrants. So this is only true when x is between 0 and pi. Okay, now we're going to play with what happens just a little bit. We'll probably play with a bunch of these, in class. And I'll show you how to deal with those. But what happens when x isn't between 0 and pi? We know what happens if x isn't between -1 and 1. Remember what we did with inverse cos? We run into trouble. We end up in this situation, right? There is no angle such that the sine of that angle equals 2, because sine only spits out values between -1 and 1. Okay? But we'll play with that in class. That's an interesting test. It'll be fun for you. Okay, now let's move on to the inverse tan. This is a good one. It's much simpler to see, I think. So by the time, I'm going to change the color of that. That looks a little too ominous. At this point, hopefully, let's do f of x equals the inverse tan of x. Excuse me. Okay, so remember, we're going to do y equals tan x first. So remember how this guy works? This one's a lot simpler to play ball. I know from -pi12, and whoops, what is going on with my brain today? -pi12 to +pi12, right? And then if I stumble out here, let's see, 1, 2, 3, 4, 5, 6, 7, 8. This is going to be, what, 3pi12? 3pi12. Right here is going to be pi. This is going to be 0. And our function, remember, we have these vertical asymptotes at every pi halves. These guys look like this. So, and tangent looks, whoops, tangent looks like that. And like that. Ad nauseum, right? Ad infinitum. They go forever, and then over here as well. That's what tangent looks like. However, can you tell what one-to-one sliver we're going to take? Because clearly, tangent's not a one-to-one function, and if I'm going to do its inverse, then I'm going to need a one-to-one sliver. Well, that's easy. Take the middle one, right? Take that guy. All right, now let's steal some points, just for giggles, because we know we got some free points on tangent. We like tangent, right? I know I got 0, 0. I've also got pi-fourths right here. This is pi-fourths and 1. This right here is -pi-fourths and -1, right? In the fourth quadrant, remember, we know that all students take calculus, so in the fourth quadrant, we know that tangent is negative. That, and I'm looking at the function. So when I want to sketch the inverse tangent, if I want to do y equals the inverse tangent of x, remember y equals f of x, I can do them interchangeably. Now, look at the first free piece of information. There's a freebie here. I suppose, just to be honest, I know, let's write down our domains and our ranges, because that'll help us, okay? Excuse me. Well, the domain. Now remember, we're only taking this sliver. We know that the domain is really all reals, right? All reals, except minus what? Pi halves, whoops, pi halves k. In other words, except, this is minus is the wrong word, so except. In other words, theta cannot equal pi halves times k, where k is an integer, all right? That's where my vertical asymptotes take place here, because that's when cosine goes to 0. We know this already. We also know that the range is from -infinity to infinity. However, look, what are we stealing for our little one-to-one sliver right here? I don't need from -infinity to infinity minus pi halves k. All I need is from -pi halves, this is the one-to-one chunk, from -pi halves to pi halves. Now this time it's non-inclusive, because at -pi halves and pi halves, we've got those vertical asymptotes. Now, why is that helpful? Well, hopefully by now you know why it's helpful. Now, here's something cool. Remember, this is x equals negative pi halves, and this is x equals pi halves. Those are my vertical asymptotes. So what does that imply on the inverse? Well, you should know this, right? This is going to be y equals positive pi halves. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm just making sure I look pretty here. It's hard being pretty, right? I'm going to have horizontal asymptotes because x and y on inverses change places. So this horizontal asymptote is y equals pi halves and y equals negative pi halves. Isn't that sweet? All right, so let's see. 0, 0, well, that's a freebie, right? You can probably already see what this is going to look like. Let's see. I'm going to have to go pi fourths comma 1 is actually going to end up being 1 comma pi fourths, isn't it? So right here, because x and y changes spots, so 1 comma, sorry I'm writing so small, 1 comma pi fourths, and then what did I do over there? I want to keep my scale kind of preserved, and then this is going to be negative 1 comma negative pi fourths, and look at what happens. Isn't that cool? That's awesome, isn't it? That's really cool. Now let's write down the domain. The domain, easy. Well, take the range, right? Nothing to it. So it's negative infinity to infinity. That's cool. And what is the range? Well, what values do I get? I get from negative pi halves to pi halves. But this time it's non-inclusive because it's impossible for me to hit negative pi halves and pi halves because y equals those values are horizontal asymptotes. Well, what does that imply? Really simply, all right? I'm not going to rewrite f inverse of f of x equals x. I promise. All right, you ready? If I take the tangent of the arc tangent of x, that should be a minus 1, all right, of the arc tangent of x, what should that equal? Well, better equal x. When? Well, look back at tangent. Tangent's domain, right? Or excuse me, tangent's domain. Tangent's range, it's always going to spit out values from negative infinity to infinity. We have nothing to worry about with tangent. Its range is always just spit it out. So this is for x between negative infinity and infinity, because tangent's allowed to throw out any value between negative infinity and infinity. Now, arctangent or inverse tangent is a different ball game. Right? The inverse tan of tan x equals x. However, arctan's value, its range, its values that it spits out are only between negative pi halves and pi halves. So what we end up with is this is only true when x is between negative pi halves. Whoops. Excuse me. That's not an equal to, right? And pi halves. Isn't that cool? Now the question becomes, what happens if x isn't between negative pi halves and pi halves? What do we do then? Again, we're going to play with those in class for sure. Now let's go ahead and take a look at what your calculator is going to make. This is kind of like a cooking show. And kapowie! All right, let's look at this guy real quick. I've got all these set up for us, okay, but they're turned off. Now, I'm going to turn on the inverse sine, excuse me. And here we go. And it's turned on, and wazam! Look at that. All right, now if you want to take a look at my window, here's my window right here. Check it out right there. I went from negative 1.5 to 1.5. My y-min is from negative 3 to 3, just to give us a little space. All right, and that gives us that curve that we're looking at. All right, now clearly the calculator draws it a little bit better, but notice it stops over here at negative pi halves, and it stops over here at, I'm sorry, we've got negative 1 comma negative pi halves, and we've got 1 comma pi halves. Okay, now I'm going to turn this one off. Let's take a look at the other guy. Oops, get over there. Whoops, oh sorry, duh. All right, I'm going to go ahead and turn this guy off, and let's turn on sine, or arc cos. Okay, turn that sucker on. And booyah! See, notice, starts at, excuse me, it starts at where? 1 comma 0, and it finishes all the way over here at -1 comma pi. Okay? Nothing to it. And I'll turn, whoops, I need to turn that off, don't I? Turn off cos. Let's look at inverse cotan. Turn him on. And look at this. Booyah. Just like we did. Nothing to it. Negative pi halves to pi halves. Pass through 0, 0. Passes through 1 comma pi fourths. -1 comma -pi fourths. Cool. I hope you enjoyed that. We're going to play a bunch with these. I promise you by the time we're done, you'll be really good at these. All right? So thanks for your attention and have a great day.